Hi students. So I just want to go over the chapter Evaluating Limits Analytically Part 3 with you. So with this, remember that we are kind of working off the textbook at this point, and so the section 2.3 doesn't really apply here, but it's just evaluating limits, and we're going to be working with the squeeze theorem. So I have a couple of examples planned for class, and then I'll just go over the couple that I have in here with the squeeze theorem. First, I have a limit from yesterday, where we're taking the limit as x approaches -1 from the left, from the right, and then the two-sided. So we have the two-sided limit here. So we'll check out the first two first. Before we do that, we're going to take the x plus 1, the absolute value of x plus 1 over x plus 1, and we're going to simplify this. So it's equal to x plus 1 over x plus 1, which is equal to 1 if x is greater than -1, the place where it's equal to 0, and it's equal to the opposite of x plus 1 over x plus 1, which is equal to -1 if x is less than -1. So we have these two expressions that if we look at a graph of this thing, you can kind of see what's happening with the limit right off the bat. So with this one, it looks like here, if we go to 1 and -1, if x is greater than -1, I guess I should put the y-axis on here too. Let's put that over here. Let's put the y-axis on here, make this the x-axis. So if we're considering that line, x is equal to -1. Okay, that's our center focus here. Let's get rid of this. And if x is greater than -1, we have this function. It's equal to 1. So this is the function y is equal to 1 above the x-axis. When x is greater than -1, and here's the -1 value, and it's equal to, y is equal to -1. So we can kind of see that from the left-hand side, which is what we're doing here, coming in from the left, our function value is approaching -1. Okay, so the answer for the first one is -1. Coming in from the right-hand side, so from the right-hand side, our function value is 1. Coming in from the right-hand side, our function value is always 1. So this one is 1. And then we would say that the limit does not exist for the last one because the limit as x approaches -1 from the left does not equal the limit as x approaches -1 from the right. So there are your three answers here for the first problem. And we'll move on to the squeezing theorem. Okay, now the squeezing theorem is kind of this idea, and I presented in class a little bit about this, but it's an idea where what we're going to say is that one function, if we say we have a function f of x, and maybe it moves something like this, and then we have a function, we'll call it h of x, and maybe it goes something like this. So you can see that there's this little neighborhood where they kind of join in here, right? Okay, so that's what I'm going to focus on that. And so I'm going to h of x a different color. Let's make that red. Okay, so h of x is red. And picture an f of x then between these two functions where at least in a neighborhood, g of x is in between there, right? So what we would say is that f of x is the greatest, h of x is the lowest. So if we said h of x is less than or equal to g of x is less than or equal to f of x, then we would say that g of x is sandwiched or between the h and f. So what we're going to do is we're going to use this fact that we can say, all right, well, we know the limit of h of x, and we know the limit of f of x. That may help us to find the limit of g of x, which is squeezed between h. So let's take the next two. Dealing with trig functions, it's always kind of interesting. So we have the limit as x approaches 3 of x squared. Notice by direct substitution, we get 3 squared minus 3 times 3. And then we have cosine of 1 over 3 squared. So we can work this out, and we would probably get an answer for this. So it makes it a little bit easier, though, if you take the function. I mean, I don't know what cosine of 1 over 3 squared is, 1/9, but let's see what we get here. So we have the limit as x approaches 3, right? So I'm going to do it like this. I'm going to say that cosine 1 over x squared is then caught between two values, and you guys know that the range of cosine goes from -1 to 1. So then what I'm going to do is I'm going to add a multiplying factor of x squared minus 3x. So I'm going to have x squared minus 3x over here. It's on the inside, and stretch it, give a little bit more space here. X squared minus 3x here. So I'm going to say -1 is less than or equal to, okay, -1 times x squared minus 3x is less than or equal to x squared minus 3x times cosine 1 over x squared. And let's scooch this out here a little bit further. And then that's less than or equal to 1 times keep messing that up. Okay, so 1 times x squared minus 3x. Okay, so now what I want to do is I'm just going to leave things as they are. Now I'm going to take the limit of all three parts, because you want the limit of this middle section right here, right? So let's see what we get on the left. So we have -1 times 3 squared minus 3 times 3. So that gives me -1 times 0. We know that's less than or equal to. In the middle, oh, I'm sorry. Here, I need to go back just a second. I need to write this limit idea here. So we have the limit as x approaches 3 of -1 times x squared minus 3x is less than or equal to the limit that we hope to find, and that's of x squared minus 3x times cosine 1 over x squared, which is less than or equal to the limit as x approaches 3 of x squared minus 3x. So you can kind of see from what we just did here, we're going to plug in 3 and we're going to get 0 on the left. So we have the limit as x approaches 3 of x squared minus 3x times cosine 1 over x squared. And that's less than or equal to 0. So by the squeezing theorem, I'm going to do an abbreviation, SQ, the squeezing theorem, the limit as x approaches 3 of x squared minus 3x cosine of 1 over x squared is equal to 0. Because what you've done is you've squeezed the expression in between two values. Let me put an equal there. That are equal to 0, so the limit must be equal to 0 if it's in between 0 and 0. And we're going to do the same thing for the next one. Now, that one we actually probably could have just put it in a calculator and figured out what it was. And it makes sense that it's just going to be 0 times cosine of 1 over 3 squared, right? That one we could do by hand by direct substitution. But the next one, you're not going to be able to. So illustrating it, the first one, just using a rule with problem that we could do direct substitution with. Now, for this one, notice that when you do direct substitution here, you get 0 squared times sine of 1 over 0. So you've got 0 times sine of some kind of infinity, but we don't even know that at this point. So, in fact, that would be a two-sided limit, and I think we have problems with that. So in that case, we're going to take sine of 1 over x, and we're going to place that in between 1 and -1 because that's the range for the sine function. Okay, then we're going to multiply each part of the inequality by x squared to complete the expression. So it'll be x squared times each portion of this inequality to get our expression that we want in the middle. So it's going to be x squared times -1 is less than or equal to x squared times sine over 1 over x, and is less than or equal to x squared times 1. So now that we have our expressions, we're going to take the limit of the whole thing. The limit, we want to find the limit as x approaches 0, and our expression is then negative x squared is less than or equal to, then we have the limit as x approaches 0. So we have the limit as x approaches 0 of x squared sine of 1 over x. That's the limit we want to find. And then we have is less than or equal to the limit as x approaches 0 of just x squared. So now when we do a direct substitution, we're going to get negative 0 squared, which is going to be 0. So we get 0 is less than or equal to the limit as x approaches 0 of x squared sine of 1 over x is less than or equal to 0. Therefore, by the squeezing theorem, sometimes called the sandwich theorem, the limit as x approaches 0 of x squared sine 1 over x is equal to 0. And there you have it. There it is. There you go. Okay, see if that's helpful for you. And this is Allen out. I'll see you when I see you.